You are listening to Tech Gumbo on Talk 107.3 FM, WBRP, Baton Rouge's local talk and information leader, brought to you by Gulf South Technology Solutions. You can reach us on the phone.
225-216-2169.
And on the web, gulfsouthtech.com. Gulf South Tech brought to you for all your business, computer, and IT network needs. At Gulf South Tech, we give you the
right solution, right response, right now.
Very good. So here we are in our third segment. We have with us our guest today, Mr. Matt Long, an old buddy of mine back from the college days. How you doing, Matt?
Doing great. Hey, guy. Good to hear you.
You too. Matt he's a principal software engineer at Microsoft, and Matt's got some really cool things going on right now. So, Matt, tell us a little bit about what is exactly you do with Microsoft. Let's start there.
I'm a software engineer, and I work on the commercial what they call the ISV team, and that's a team of people that work with our partners that develop software on our platform and distribute that to their customers.
Okay, very cool. So, but the thing that's brought you some notice here as of recently is the Pegasus Mission. Tell us about how you got started with the original Pegasus Mission and where you're going now.
Yeah, it's kind of a long story, but to shorten that up a little bit, we started working on some technology a very, very long time ago to essentially break down the barriers between the natural, physical, and the digital worlds. And what that really means is that the things that we use in our daily lives, like a cruise control system on our car and the things that are around us all the time, there's really no impedance mismatch because we as human beings can use them very effectively. But when we start to take this to the digital world, in specifically like the cloud and places like that, that's where these things kind of begin to break down. So we had worked on some experimental technology for a very, very long period of time, and we were ready to kind of show that at an internal conference. And we had this incredibly fast, low latency technology that ran in the cloud, and we didn't have a good way to demonstrate that. And so Mark Nichols and I came up with this idea that we would build a high altitude balloon and integrate that as an experience for users. So they really wouldn't have to know anything about the technology, but they could experience in real time, and meaning like an order of magnitude faster than a reaction time of an Olympic sprinter. That's how fast this is. That they could experience this high-altitude balloon flight by watching it. And as it happens thousands of miles away, they could actually see all the interesting things that were actually happening in the upper atmosphere. And that's kind of how we got started in kind of the high-altitude science area.
So Matt, I'm sorry, this is James, and it's really interesting and exciting to talk to you about this project because, we've had several folks from Microsoft on, over the, our tenure, here with the show, and we talk a lot of acronyms and things like that, and the ISV for our listeners is actually an independent software vendor. Is what those are known as in the partner space, if you will, as an ISV partner, or in our case, a VAR or infrastructure partner or something like that. And so to hear that Microsoft is involved and doing this type of deal it's phenomenal. It's just really fascinating to me because most of the time we hear ISV projects that are kind of business case, related or maybe business focused. And I see where this is as well, but it's also really cool.
Yeah, so the partners specifically the partners that I work with, they work around a lot of things with the Internet of Things, about these devices and things like that. And they aren't necessarily engaged in this. This was a project that had a nexus of it almost 10 years ago. And as it began to grow, we began to collaborate with Microsoft Research, and they had some very, very interesting technology that kind of was the last part of the missing piece of this puzzle. And once we kind of created that, we were kind of in this position, and we had this really phenomenal abstract thing, but we didn't have any way to relate it to people. That's usually the most difficult thing. And And so when we decided to do Pegasus Mission, we said, oh, we're going to do some risky things. We're going to do some things that just might not work out. That really attracted people to go out and watch something because it takes them to a place they can't go. You can't go 20 miles up in the upper atmosphere, and the view from that is absolutely extraordinary. So when we did this, what kind of happened was we went on this first flight and we flew and we were able to actually show you this telemetry from this high altitude craft in real time, the air pressure going down to 2% of what it is here and temperature dropping to minus 75 degrees Fahrenheit, all these interesting things happening. But when we got the video back, you could see the edge of the atmosphere stopping. The visible atmosphere literally stops because it's so thin. It's just a glow above the surface of the Earth. And you can see the curvature of the Earth from that altitude. And then above that is the blackness of space. In the middle of the day, the sun is sitting in literal space, which you obviously can't see from the ground. And that just changed the dynamic. People just wanted more and more of that.
Okay, so tell us what's the difference between the original Pegasus mission and Pegasus 2? What's different this time around?
So this time around, we learned a lot from Pegasus 1 because everything didn't work perfectly. But Pegasus 2, we decided to really amp everything up. So we have about 38 sensors on board. We have 5 cameras on it. One of them is live video, and we're actually transmitting live video back down to the ground and then up into Microsoft Azure, and you can see through Azure streaming services, you can actually see the live video from the craft. So it's like an eye in the sky. And that's an important part of the experiment because even the manufacturers of the equipment can't tell us how well this is going to work other than theoretically it works great. So we're going to experiment with live video, and we have a 360-degree view of everything that's going on the video side. On the interactive side, we've also we have a website that you can go to, pegasusmission.io, and you can see the telemetry and the video there. But we also created phone apps. We created phone apps for iOS and Android and Windows phones. So if you have a smartphone, you basically can go to Pegasus Mission and download the phone app, and you will see the telemetry live. But you also have this fun capability to type in a 40-character message into your phone app, and you can send it to the craft in flight. And on the top of the craft, there's a tiny little display with a camera 6 inches away from it, and your message will show up on that display while it is in flight and will be photographed on the video. And you'll have your message plus the background of near space behind it.
That is so cool. So what's the total amount of time of the flight that y'all are anticipating?
So the 2-hour flight with a halo drop, and we have a halo drop on it. So what that means is that we actually control the flight operations remotely through the cloud. The command center is actually like 1,500 miles away. And we cut the balloon off at 1,000 feet, so it begins to drop, and it drops on this tiny 2-foot drogue parachute and hits about 300 miles an hour on the way down. And that descent of 94,000 feet takes about 12 minutes. And then at 6,000 feet above the ground, some other intelligence, and another 1,000 miles away, actually sends a command to the craft to deploy its main parachute and slow it down for touchdown. So that takes 6 minutes. So it's 102 minutes to the top, and it's 18 minutes back down.
And so when y'all are at the top, how long are you going to keep it up there?
Well, it's climbing at a rate of about 5 meters per second. So it's 16, 17 feet per second.
Mm-hmm.
Per minute. 16, 17 feet per second. So when it basically goes up at that 5 meters per second, and it takes it about 102 minutes to get to 100,000 feet. And when we get there, the remote intelligence basically sends a signal to it to come on down, and then we do our halo drop for depending on the altitude of where we're landing, up to 94,000 feet, and then we touch down.
Okay, Matt, we're coming up on the end of the segment. Can you hang over for one more segment with us?
Sure.
All right. So just want to remind everybody, this is Tech Gumbo here on Talk 107.3 FM, WBRP, Baton Rouge's local talk and information leader.